Right. In the last videos, I think we had a very clear discussion about tree data structures. We completed that tree data structures in detail. Now, in this session, we are going to talk about graph data structure. Okay, graph data structure in Python. Let us see what is this graph data structure, how we can able to implement this graph data structure. Maybe, sir, I'm going to take two sessions today and tomorrow. Maximum timings will be same. 5:30 around that I will start. So today, the first part of the graph we are going to discuss, and tomorrow we are going to see the second part. So in this first part, we will see what is meant by graph, what are the various points related to the graph we will see. So here a graph is nothing but, okay, a graph is finite set of, or a graph is non-linear data structure. Okay, non-linear data structure. A graph is nothing but what? Non-linear data structure that consists of, okay, that consists of the following two components. The following two components will be there. So what are that components? A finite set of, vertices, a finite set of vertices, also called as nodes. We are going to use the term called nodes also. Okay, and the second one is what? A finite set of, a finite set of edges, a finite set of edges. Okay, edges will be there. So in the form of, u comma v, the form of u comma v, like this we will represent it. Okay, so where u and, okay, u and v are two vertices in the graph, in graph, like this we have to define. So if you want, just I will provide some examples so that you can able to understand very well. Okay, let us see some examples I am going to take here. So this is nothing but one simple graph I am taking. This is nothing but the first vertex what we have, and this is another vertex what we have, and this is another vertex what we have, like this. Suppose, sir, is it a graph or not? Yes, it is also a graph. It is also a graph. Suppose I am going to take like 0, next and after that 1, next and after that 2, next and after that 3, like this. Then is it a graph or not? Yes, it is also graph. And if you see clearly, here total how many vertices are there? How many nodes are there? 3 nodes are there. In this example also we have 3 nodes. In this 4 nodes. And coming to the edges, how many edges are there? 1, 2, 3, right? So 0 to 1, one edge, and 0 to 2, another edge. Can I say 1 to 2, another edge? In this case, how many edges? 2 edges are there. 0 to 1, yes, another one edge. Then 0 to 2 is the another edge. So there is no connection between 1 and 2. Okay, it is not a tree, but it is a tree. Why? Because there is no loops. If there is a loop, then it is called as what? Graph. Okay, so what about here edges? So 0th node, 0th vertex is connected with the first vertex, and 0th vertex is connected with third vertex. Next, first one is already connected with 0, that pair we got, and 1 is connected with 2. What about 2? 2 is connected with 1, it is already there. 2 is connected with 3, like this we have. So this one is called as what? A graph example. There are two types of graphs are there. Okay, anyway, that I will explain later. Here you can see there are two types: direct graph and then undirected graph. Directed graph means direction will be there. Undirected graph means directions won't be there. So don't worry, I will take one example and I will demonstrate. Can you please confirm the definition of this graph and how we are going to represent this graph? Is it clear for you people?
Clear, sir.
Yes,
Right.
sir.
Right. So this image I already saved, it will be there in your running notes. Next and after that, so there are different types of different terms different terms are there related to, there are different terms of there related to graphs. Let us see one by one. The first one is nothing but I can say directed graph. So what is mean by directed graph? A graph with directions, okay. So that means from source to vertex, is there any possibility is there or not? And reverse won't be there. A graph with directions are called as directed graph, something like one way, okay. So in only one direction we can able to. And the second one is there, which is nothing but what? Undirected graph. So we can say it is nothing but, so there is no direction. A graph without any direction for edges. Okay, edges are called as what? Undirected graph. Okay, so it is nothing but what? Two-way access. If you want example, just have a look once. So I have one graph is there here. So this node is nothing but 0, and this is connected with 1, and this is connected with 2. So 1 and 2 are connected. So it is what type of graph? It is nothing but undirected graph, because there is no direction here. Okay, there is no direction here. Now, sir, can I take directed graph? Yes, same thing we can represent like this: 0, okay. So 1 and then 2 like this. So 1 to 2. So do you know 0 to 1 a direction will be there, 1 to 2 direction will be there, and the 2 to 0 direction will be there. In the case of direction, you have to represent the edges like 0 comma 1, next and after that 1 comma 2, next and after that 2 comma 0. That's all. But in undirected graph, so 0 to 1 edge is possible, and 1 to 0 is also possible, because there is no arrow marks. You can travel in both directions. Similarly, 1 to 2 edge is there, and 1 to 0 already I have mentioned. Then 2 to 1 edge is there, 2 to 0 is also edge there. Have you observed? Like this we are going to represent. So 0 is connected with 1, and 0 is connected with 2 also. 1 is connected with 0, 1 is connected with 2, 2 is connected with 0, 2 is connected with 1. Like all combinations we are going to take. Okay, so this is nothing but what is mean by directed graph and undirected graph. Are you clear with the directed graph and undirected graph? Please confirm.
Yes, sir.
Yes, sir.
Right. Coming to the representations, sir, how to represent these graphs? We can represent the graph. So in programming, by using two ways. The first one is nothing but, so adjacency matrix representation. Okay, adjacency matrix representation. And the second one is adjacency list representation. But regularly we are going to use adjacency list representation only. Okay, because it is very difficult for us to represent okay, adjacency matrix. But anyway, programmatically we will use a list, but theoretically how it will be, I will demonstrate. Just have a look once how we are going to represent. Suppose consider, so I have one graph is there. Okay, so that graph is nothing but zeroth vertex, okay, which is connected to 1, and it is connected to 2, and it is connected to 3, and it is connected to 4, and it is connected to 0, and there is a communication between 1 and 3, and there is a connection between 4 and 1 also. Like this I have a graph. How to represent these in the matrix format? If you want to represent a matrix format, so try to represent all the vertices. How many vertices are there? We have 4 vertices are there. 0, 1, 2, 3, 4. For 5 vertices are there. Try to represent all these things in the form of a matrix. Now, please observe carefully. Is 0 to 0, is there any communication? No. And 0 to 1, is there any path? Yes. 0 to 2, is there any path? No. 0 to 3, is there any path? No. 0 to 4, is there any path? 1. So if there is a path, you have to take 1. If there is no path, you have to take 0. 1 to 0, yes, path is there. 1 to 1, no path. 1 to 2, yes, path is there. 1 to 3, path is there. 1 to 4, path is there. 2 to 0, path is not there. 2 to 1, path is there. 2 to 2, 0. 2 to 3, path is there. So 2 to 4, path is not there. So 3 to 0, path is not there. 3 to 1, path is there. 3 to 2, path is there. 3 to 3, path is not there. 3 to 4, path is there. So 4 to 0, path is there. We have to take 1. So 4 to 1, path is there. 4 to 2, path is not there. 4 to 3, path is there. 4 to 4, path is not. Like this we are going to get. This is nothing but what? Adjacency matrix representation. Sir, how to represent in adjacency list? So first node is nothing but what? 0, right? First vertex is 0. Second vertex is 1. So third vertex, fourth vertex, fifth vertex. Like this I am taking. Now I will maintain a list here. So which nodes are connected to 0? I have to list out. So which nodes are connected to 0? 1 and then 4, right? So I will take 1 comma 4 in the form of a list. Which nodes are connected to 1? So 0th node is connected to 1. So second node is connected to 1. Third node is connected to 1. Fourth node is connected to 1. Which nodes are connected to 2? Which nodes are connected to 2? So 1 is connected, 3 is also connected. So which nodes are connected with 3? So here 0 is not there, 1 is connected, 2 is connected, 4 is connected. Which nodes are connected with 4? 0 is connected, 1 is connected, 3 is connected. Like this we have. Okay, like this we have. I think you people got some idea about this. Okay, this matrix representation is called as matrix representation, and this kind of list representation is called as adjacency list. Of course, in the matrix it is very easy to implement. Anyway, we will see how we are going to do that. But adjacency list we will give more priority. Why? Because easy, right? We have to maintain a list, that's all. Beyond that, nothing. Are you clear with this? Please confirm.
Yes, sir.
Clear? I request everyone to please respond. Clear? Yes, Bharat, Ranjit, YP, Laku.
No, I have just joined, sir. So
Yes, sir.
At least by seeing the diagram, somewhat you got.
yeah, yes, sir. Yeah, I have the idea of this one.
Right. So now we will see how we are going to, okay. So how we are going to represent this, okay. How we are going to represent this, we will see in detail. So now observe carefully. We are going to implement a program to represent this graph, okay, to represent this graph. Maybe I'm going to remove this, or better, I will minimize this. Yes. So we will see a program for both. Okay. Maybe first one we have to think and we need to write. So second one, it is very easy to write. Let us see. Okay. So I'm going to define one function for doing this activity. Okay. I'm going to define one function for doing this activity. But if I want to represent this graph, we need to take the matrix. We need to take the matrix representation. Let us consider a list. So how many number of vertices are there that we have to provide in advance? In this example, 1, 2, 3, 4, 5. 5 vertices are there. 5 vertices are there. So we are going to create a list. So again, inside this, we are creating an empty list with all the values as a 0. Okay. So for each I value in the range of, so total how many vertices are there? So those many times I am going to generate. Now I want to print a list. Now have a look once. So we can print this list or not? Yes. If you want to just have a look once. It is there in test folder under py space test.py. You can see we got like this. But again, this one we have to multiply. What we have to do? So 0 into length of v or length v only, right? V like this I am taking. Now let us print, right? So I want to print this in for each row value. So in the list, I want to print the tie value. Now have a look once. Is it coming in the matrix style? Still, if you want to get in detail in matrix style, we have to write a function. So better I will go with so print graph function, where I will take this list. That's all. That is sufficient. So how you can write this function? So def print graph I am taking, which will take that list and it will print all the elements. So how to print for each I value in the range of length of list, for each j value in the range of length of list, because number of rows and columns are same, right? So what will happen? We are printing L of ij in the form of matrix, and I will give space as a separator. Once if you come to the next line, I am giving new line character. Now see, is it coming in the matrix format or not? Yes. Now we have to accommodate zeros and ones. Anyway, already zeros are there. If there is a connection, then we need to represent that as a 1. Sir, up to this, are you clear? Up to this, are you clear?
Yes, sir.
Right. So now, before printing the graph, I want to add the edges. Okay, before printing the graph, I want to add the edges. I will define a function, okay, or I will call a function like add edge. Add edge. So which will take your graph and which node to which node connection is there? 0 to 1. There is a connection, right? So I will define a function which is going to add that particular edge. Okay. So add edge of list I am going to take u and then v, because I told in the definition itself u is nothing but one node and v is nothing but another node. Is there any communication between these two? Yes, that's only we have mentioned here. Now you have to make an edge is there from u to v. So how to add that edge? Can I take so L of, okay, L of so 0 comma 1, 0 comma 1. That means L of uv is equal to, can I set 1? Can I set 1? Yes. Now have a look once. Let us print the result. Sir, is this 1 is came or not? Yes. Now please observe carefully. 0 to 1 connection is over. Next term, is there a connection between 1 to 0? Yes. That one also I am going to mention. Like here u and then here v. Like this. Now let us represent. Sir, is it coming? Here also it is there. Okay. Now second edge. 1 to 2 is there. Okay. 0 to 1 completed. 0 to 4 is there. Another edge is also there. 0 to 4. So 0 node is over. Now we have to take 1. Which nodes are connected to 1? 0 is there, but it is already added. Next 4 is there. Okay. Next 1 to 4. So next one is what? 1 node is connected with 3. 1 node is connected with 2. Like this I am taking. Sir, is it coming? Yes. First row you can see. Is it there? Second row you can say. Is it there? Yes. Because we connected only 0th node to remaining nodes. First node to remaining. How to connect with second node? Second node having connection with 1, but that is already registered, and it is having a connection with 3. Now the node 3 is having connection with 4. Is it mentioned? No. Try to take. And node 3 is having a connection with 1. 1 to 3 already mentioned. Then a node is having a connection with 3 to 2, but 2 to 3 is already mentioned. So that's all. What about 4? 4 to 0? It is already mentioned. Then 4 to 1, it is already mentioned. 4 to 3, it is also already mentioned. So no need, right? Now have a look once. If you run this code, what will happen? Sir, 0 1 0 0 1 1 0 3 1. So 0 1 0 1 0. So 0 1 1 0 1 1 1 0 1 0. Sir, is it matrix representation or not? Yes. This is the way how we can able to represent this particular graph in matrix representation. Sir, it is somewhat easy to understand. Why? Because you can see wherever connections are there, that I am replacing with 1. Wherever connections are not there, that I am replacing with 0. So except that remaining things are same. So are you clear with this concept? Whatever I explained, please confirm.
Yes,
Yes,
sir.
sir.
Clear, sir.
Right. So now what I am doing is, I don't want to represent this in the matrix style. Okay. By default, we are going to use, 1 second. So by default, we are going to use only list representation. Okay, that is nothing but adjacency list representation we are going to take by default. Okay, let us see. 1 second. Yeah, is charger connected? 1 second. Right. So now we will see how you can represent in the adjacency list representation. See, the problem with this matrix representation is, so if there is a connection, we have to highlight that part only. But in this representation, we are getting whenever connection is not there, that part also we are concentrating. That is the biggest problem what we are facing here. Okay. So if there is a no connection, that part also is indicated in the graph. That is the biggest problem what we are going to face here. Now, sir, we will see how you are going to represent in this particular list representation. Have a look once. The program is the same, sir. Okay. But I want to take all these matrix values. I will take empty list. Okay. For each I value in the range of V. So how many vertices are there? I'm going to take one empty list. One empty list I'm going to take. So assume this add edge function is there, but I will use some different technique to add. So as of now, just I am removing all these things. Now I am printing the graph. Now see what will happen. Now see what will happen. I am going to run the code. Sir, initially L of ij is also not there. 1 second. In the printing, we have to use some different technique. Okay. What is that technique is? For each I value in the range of length of list, can you please print that length of list, that length L of I we are printing. Now have a look once. Sir, as of now, the edges are not added. That's why we are getting empty list. So 0th node is not connected to any node. First node is not connected to any node. Second vertex is not connected to any vertex. Like that, it is printing. Now my requirement is, along with this, can you please I value? So can you please print I value? So that what will happen? You can see the difference. So 0th node is connected to which nodes? As of now, nothing. So first node is connected to which node? As of now, nothing. Okay. Now what we have to do? We have to add these edges. But how to add, I will explain. Anyway, add function is there. How we are going to add the edge, I will explain. Just let me take the first one, sir. Add edge function we are taking. So for this list, there is a connection from vertex 0 to vertex 1. How to represent that here? Please listen. Can I take L of U dot append of V and L of V dot append of U? Can I take like this? Because it is representing the list. We are adding 0, 1. Okay, so that means what? 0th node is connected to first node. Can you please add this 1, okay, to this L of U? L of U value is what? 0. L of 0 is added with 1. L of 0, you can see added with 1. Good. Okay. But opposite also we have to do, right? That is, if there is a connection between 0 to 1, and there should be a connection between 1 and 0. Have you observed that part also we have done in the reverse, L of V dot append of U. So let me take, is there any other edge from 1 to 0, 0th node? So 0 to 1, this edge we have seen, no problem. And we have another edge, 0 to 4. How to add this? Can I take L of 0 comma 4, 0 comma 4 automatically? So for the 0th node, 4 will be attached. So that means here you can see. And similarly for 4, 0 will be attached. So if you want whatever I round up by using the pen, you can see that part will be highlighted here. As of now, 0th node is connected to first node, 0th node is connected to fourth node, first node is connected to 0th vertex, fourth vertex is connected to 0th vertex. Is it correct, clear up to this? So we can add a few more edges that I will take care. Are you clear with this, friends? Please confirm.
Yes, sir.
Clear?
Clear, sir.
Now, so the next step, again I am calling add edge by passing the list. So 0th node is completed. Okay, so first node is also completed, right? No, only 0th node I added. So now we have to take the first node connected to these 4 links, 1 to 0, 1 to 0. Already this one added, so 0 is added. No need to include this. Sir, 1 to 4, which is not yet added, try to take 1 comma 4, 1 comma 4. So that what will happen? 1 in first location, I mean in first vertex list, 4 will be added. Okay, and similarly in the fourth vertex, 1 will be added. Okay, right, this one is okay. 1 to 3, 1 to 3 is not yet added, right? So just I am taking 1 to 3 according to order I am following. And 1 to 2 is also not yet added. So for 1, 2 will be added, 3 will be added, 4 will be added. And for 2, 1 will be added. For 3, 1 will be added. For 4, 1 will be added. Like this we have. So in this example, 0 completed, first node connections also completed. Let me take a second node, sir. Add edge of 2. So second node is connected to 1, but it is already mentioned. Second node is connected to 3. So okay, so is it mentioned? No, we have to take. Then what about the third node? Third node is connected to 4. It is already mentioned. 4 comma, no, it is not mentioned. 3 comma 4. So third node is connected to 1. It is already there. Third node is connected to, it is also already there. So fourth node is connected to 0. It is already there. Fourth node is connected to 1. It is also already there. Fourth node is connected to 3. It is already there. So no need to take. That's all right. So now you can see all these things will be added. If I am not wrong, have a look once. So 0, 1, 4. So 1 is connected with 0, 2, 3, 4. You can see. So 2 is connected with 1 and then 3. So 3 is connected with 1, 2, 4. 4 is connected with 0, 1, 3. Like that, we can able to represent the graph in adjacency list representation. Okay. So when compared with matrix, if there is no edge, instead of representing 0, we are taking the normal representation. Beyond that, nothing. I think you people understood the terminology, what I explained here. Are you clear with this?
Yes, sir.
Please confirm everyone. Are you clear with this?
Yes, sir. Clear.
Right. Now, let us go for next example. So I will take this a screenshot. So what is the next example here we have? See, I want to explain some theoretical definitions. What is that theoretical definition is? So if you see stack, we performed a display operation manually by following LIFO technique. If you take a queue, we followed display operation by using the technique called first in first out. So we have linked list is there. we performed a display operation manually. Okay, we performed display operation manually by taking the elements. Okay, manually from beginning to ending. Sir, when we are taking tree data structure, we perform a display operation by using in order. So pre-order, post order. Okay, next and after that level order. Like this, multiple approaches we have seen. What about graph? For graphs, you can represent or you can visit the elements present in the graph in two ways. One is nothing but BFS, another one is nothing but DFS. So BFS means what? Breadth first search. Okay, breadth first search algorithm. And what is the second one? Depth first search. Okay, depth first search algorithm. So if you want to perform this display operation, we have to go for depth first search and then breadth first search. First, we will see breadth first search. How you can able to do this? We will see. Sir, very simple. Here, how you can able to search? We are going to take one example and I will demonstrate so that you can able to understand very clearly. So let us consider a simple graph for easy understanding purpose. So same graph we will use even for depth first search also. For example, consider I have a simple graph is there called 0. Okay, this node is connected with 1 and this node is connected with 3, something like this. Okay, and 0 is connected to 2 and 2 is connected to 3 and even there is a connection between 2 and 3. So if you want to do this depth first search algorithm, you have to take the source vertex from where you need to visit. For example, consider I want to visit from 0. Okay, I want to visit from 0. Then what we need to do is first try to identify the adjacent nodes for this 1. For this 0, which nodes are adjacent? Try to visit those 2. Okay, and for this we are going to maintain one special list where how many nodes are there? So 4 nodes are there. Is first node is visited? No. Second node is visited? No. Third node is visited? No. Fourth node is not visited? No, because there may be having cycles. That's why if you perform visiting operation multiple times, which will create a confusion for you. That's why I will start from the first node. I will start from the 0. Because the source is 0, make this 0th node as a visited. Now what we have to do? Identify which are adjacent to this 0. So because in the 0, we have already represented in the form of list. Which things will be connected to this? So 1, 2. Take 1. Take 1. Is it visited? No. This is 0, 1, 2, 3. Is it visited? No. Then what we have to do? Make this as a visited and go for the next node. Sir, second node is visited? No, not yet visited. Make this as a visited. So completed. Then what we have to do? Now this element is there, right? 1. Try to identify the adjacent elements for 1. 1 is connected with, so 0. 1 is connected with 0 and 1 is connected with 2 and 1 is connected with 3. Sir, is 0 is visited? Yes, it is already visited. Is 2 is visited? Yes, it is already visited. Is 3 is visited? Yes, it is visited. Now we are going to make the 3 as a visited. Now, so these first node connections got completed. Try to take second one. Which are connected to second node? 0th node, first node, third node. Is 0 is visited? Yes. 1 is visited? Yes. 3 is visited? Yes. Now 1, 2 completed. Okay, like that we have to check every element vertex and we are going to check whether it is visited or not. Because it is something like level order traversal. In the tree, if you see like this, we are going to get 1 by 1, 1 by 1. But there is no connection between these two nodes. In the tree, cycles won't be there. But here cycle is there, right? That's why if you start from here, if you move to the end, there is no ending point. That's why I am going to take one special list which is going to keep track of whether you have visited that node or not. Okay, whether you have visited that node or not, we are going to check, and parallelly we are going to execute. I think you people got some idea about breadth first search algorithm. Okay, so here what we have to do, we have to visit each and every node. Okay, so we have to visit each node exactly once. Exactly once. Exactly once. What is the first step? Start from source vertex, whatever source vertex they have given, start from that. Okay, so now try to fetch, okay, try to fetch adjacent nodes, okay, adjacent nodes for x, okay, for a node. Okay, then what we have to do, so visit all adjacent, okay, all adjacent nodes, and repeat this process. Okay, and repeat this process for each node present in graph. In the graph, how many nodes are there? For every node we have to apply this approach. This is nothing but what we have. Sir, what data structure, okay, what data structure we have to use for this? So I'm going to use q here. Okay, I'm going to use q here. So how we can able to use q? Please have a look once. Sir, theoretically up to this whatever I covered, is it clear for you?
Yes, sir.
Now let us have a look once. So what is the output that we are expecting for this? Please concentrate. Please concentrate. So here I am going to maintain one queue. Empty queue is there like this. Please listen. So what is the starting vertex? Starting vertex source is nothing but what? 0. So now what I am going to do is I will put that 0 into the queue. I will put that 0 into the queue. Now can you please make this particular 0th node as visited? Okay, sir, 0th node got visited. Then what we are going to do is remove this 0 from the queue. Remove this 0 from the queue and print in the output. Then can you please cross check? So with this starting vertex, which nodes are connected? For 0, which nodes are connected? 1 and 2. I am taking the first node. Is it visited? No, it is not visited. Then can you please append that into the queue? So now make this particular node 1 as a visited. Okay, make this node 1 as a visited. So automatically what we are going to do, so we will go for the next one. Is a queue is empty? No. If a queue is empty, what we have to do, we have to stop. Since a queue is not empty, then we are going to take the next element. What is the next element? If you remove, one will be removed. That I am going to take here. Now so for each u value present in the source, what is the source that we are using? What is the starting index? 0, right? For that 0 only we have taken this. So now what will happen? Is it 2 is visited? No, 2 is not yet visited. Then what we are going to do, we will append it. Okay, we will append it. One second, somewhere the mistake is coming. One second. Yeah, better I will maintain this queue freshly so that you can understand. Yes, listen. So initially the queue is empty. We have to start from the beginning node. So what is the starting source node that we have given? 0. First step is we have to insert that into the queue. Yes, 0 got inserted, and immediately make that node as a visited. So we have to make this node as a visited. Is queue is empty? No. Then try to delete the element from this queue. Now we have to print that element. 0 got printed. Then for each element present in the source adjacent. Source is nothing but what? 1, 0. For that, which are adjacents? 1 and then 2 is there. Okay, for that take 1. First take 1. What we are going to do is, for for 1 present in this adjacency list, visited of this 1, is it equal to false? Yes, visited of 1 is equal to false. Then what we are doing is, can you please append that into the queue? Then make this node as a visited. Which node is visited? This particular node. Make it as a true. Then again we are going to select the second element. So is 2 is visited? No, not yet. Then please put that into the queue and make this node as a visited. Then what we are going to do? So is queue is empty? No. Visiting completed, first list. Is queue is empty? No. Then we have to pop one more item, which is nothing but 1. Print that. Now you need to identify which nodes are connected to 1. Which nodes are connected to 1? 0, 2 and then 3. So now take the first element 0. Is it visited? Yes, it is already visited. So now take the next element, which is nothing but 2. Is it visited? Yes. Take the next element 3. Is it visited? No. Then what we have to do? Make this node, make this vertex as a visited. Can you please append in the queue? Okay. Then what we are doing? So we are checking, is this total list completed? Yes. Then take the next element in the queue, which is nothing but 2. Pop this and print that value. Then after that, try to identify the nodes connected to 2. So 0, 1 and then 3. So 0 is already visited, 1 is already visited, 3 is also already visited. So there is no connection nodes. So these are nothing but what we have for 2. Now is the queue is empty? No. Try to delete the next element. Try to identify the adjacent elements for these 3, 1 and 2. 1 is already visited, 2 is already visited. So you can come out. Sir, is my queue is empty? Yes. This is nothing but what? BFS for this particular tree. Sir, it is a very simple, in your simple terminology, if I want to explain, take a node, identify its adjacent elements, visit all the adjacent elements which are connected. So after visiting all, take the next node and try to identify the adjacent elements. Okay. So if element is not visited, they make it as a visited. Like this you have to do, sir. This is called as what? The breadth first search. Something like it is a level order traversal. It is something like level order traversal. We need to take a queue for this implementation. In the level order traversal also, we used queue data structure only, right? Same data structure here we have to use. Are you clear with this?
Yes, sir.
Now, we will try to implement a program for this so that you can understand very clearly. I will take the same program and even we will take some complicated program also, and I will demonstrate first with example, then we will construct the code for that. Now, so please have a look once how I am going to implement. So up to this same, is it this graph? 1, 2, 3, 4 vertices are there. Okay. So add edge 0 to 1 is there. So 0 to 2 is there. Okay. Next and after that, 1 to 0 already added. 1 to 2 we have to take, and 1 to 3 we have to take. So then what about 2? So we can take 2 to 0, it is already there. 2 to 1, it is already there. Okay. Next and after that, 3 to 1, it is not yet added. Okay. No, 1 second. 0 to 1, 0 to 2, 0 to 3 is also there. No, 0 to 1, 0 to 2, and 1 to 2, 1 to 0 is already there, and 1 to 3 it is added. Next take 2, 2 to 0 it is already added, 2 to 1 it is already added, 2 to 3 we added. What about 3? So 3 to 1 it is already added, 3 to 2 it is already added, so no need to add. Now let us execute, just to print the graph and check what will happen here. So is 0th node is connected to 1 and 2, correct? Yes. Is node 1 is connected to 0, 2, 3? Yes. Is node 2 connected to 0, 1, 3? Yes. The node 3 connected to 1, 2, right? So now for this we have to implement which one? BFS. Okay. Just I am going to print the BFS. Okay. Print BFS of graph. So how you can able to call? I am calling BFS function. So for this BFS, okay, for this BFS function, just we have to pass the starting value. Okay, I will pass the list, and then starting value is nothing but what? 0. Anyway, we will see how that function is going to be implemented. So I am taking BFS. Okay, so that list is there and the source vertex is there. Now please have a look once. I am taking one visited array, okay, with all elements as a false. So with length of the list. So just now I told, right, we have to maintain that array. Then we are taking a queue. Q is equal to, already we implemented a DQ, right? We know very well how to work with this. But if you want to work with DQ, so there is one collections module is there. From that we have to import DQ. From that we have to import DQ. Yes, my queue is there. So we have all the elements we can add into this queue and you can remove. So first step is what? We have to append the source whatever you have given into the queue. So at the same time, you have to make that source as a visited up to this. Okay. Now, while queue. So that means is the queue is empty or not, we are going to check. Suppose if your queue is not empty, so take one element, anything we can take. So let us take some variable, yes, or same variable only we can take if you want. So source is equal to, can you please pop from the queue? So there is one function is there with the name pop left. It will pop from the queue and it will print that source and end is equal to empty. So that what will happen? First node is added into the queue. If you want to parallelly have a look once. So I am maintaining one queue here. I am maintaining one queue here and so 0th location is initially false. So first location is initially false. Second location is initially false. So third location is also initially false. So now what we are doing, source vertex is nothing but what? 0. We appended that source to queue. It is added to queue. Then visited of source is equal to true. I am going to make it as a true. Then while queue is empty, no, my queue is not empty. Can you please pop the element? Yes, it is 1. Now your source will become 1. Sorry, it is 0, right? Now your source will become 0. So we are printing that on the output. So this 0 will got. Next, what we need to identify? You have to see the nodes which are adjacent to this 0. Which are adjacent to 0? So 1 and then 2. How to get this list? So can I take like this? Can I take like this while q? Sir, for each I value in the list of source, right? So in the list of source, if source is equal to 0, 0th list contain 1, 2. Now what we have to do? Every element you have to check. So if visited of that I is equal to false. So then what we are doing? We will append that particular I value into the queue. Okay. Next and after that we are making that I value as a visited. Now please have a look once. So what is the first element that we added into the queue? 0. We popped that element. Okay. And then after popping, we are printing. Then we have to take every element from the source. 0 connected elements are nothing but 1 and 2. Take the first item from this 1. Is it visited? Is it visited of 1 is equal to false? Yes. Then q dot append of I, that will be added to q and then make this one as a visited. Completed. Second time the for loop is going to execute for this 2. Is it 2? We have to append into the queue. Is it visited? No. Make this as a visited. Completed. Now, so is there any other elements in this particular list? No. Completed. Now while queue is empty? No. Then source is equal to pop dot left. Pop the item which is nothing but 1. print that particular value. Sir, 1 came. Now for 1 which are connected, that we have to identify. For 1 we have 0, 2 and then 3. Take 0. Sir, is visited of 0 is equal to false? No. These total statements will be skipped. Now take next one, 2. So is visited of 2 is equal to false? No. Come out from this. Take node 3. Sir, is no visited of 3 is equal to false? Yes. Then append that value into the queue and make this as a visited as a true. Now source is equal to, we have to check while queue is empty. No, it is not empty. Pop the next item, which is nothing but a 2. So we have to print that 2. Which nodes are connected to 2? So 0, 1, 3. So unfortunately 0 is visited, 1 is visited, 3 is visited. So every node completed. Okay. Then can you please cross check is queue is empty? No. Then pop the next item, which will become 3. Try to print that item. Then identify which nodes are connected to 3, 1 and 2. Is these two already visited? So no need to print. Okay. So because of this print statement, it is printing all these 4 values. So let me run and cross check. Really, is it happening or not? Okay. Let me cross check. Sir, is the BFS of this graph is nothing but 0, 1, 2, 3 or not? Yes. I hope everyone got clarity about this BFS implementation. Are you clear with this up to this whatever I covered? Clear? Please confirm everyone. Clear up to this? Sir, please respond.
Yes, sir.
Yes,
Right.
sir.
Right. Now we will take another graph and we will check. Okay, please have a look once. I will draw another graph. You have to tell BFS for this. First node is 0. For this adjacent nodes are 1 and then 2. And for 1 adjacent node is nothing but 3. For 2 adjacent node is nothing but 4. For 3 and 4 a combined adjacent node is 5. Unfortunately for this 0 adjacent node is 5. Now I need to traverse each and every node by using BFS algorithm. So source node is nothing but always 0. Yes, can you please tell me what is the output that we are going to get? What is the first node? What is the first node? 0. Which are adjacent for this 0 that we have to visit. This is visited. Adjacent to these two. So in which order it will be visited? 1 and then 2. Then take adjacent for 1, 3. Oh, sorry. One second. Something is wrong. Have a look once. So which are adjacent to 0? 1, 2 and then 5 also, right? So it will print 1 and then 2 and then 5. Right? 1, 2 and then 5. Next. So take the next element. That is nothing but 1. It adjacent nodes are nothing but 3 and 0. 0 is already visited. 3 is not yet visited. Try to take 3. This is also visited. Now for 3 which are adjacent, 1 and 5, both are visited. Now another node is there, right? 2 in the queue, which are adjacent for this 0 and 4. 0 is already visited. Take 4 and make it as a visited. And for 4 which are adjacent to 2 and 5, both are visited, you have to skip. Like this we are going to take. So this is nothing but BFS for this tree. At least from the diagram, is it clear for you? Please
Yes, sir.
confirm. Now I am considering this as a graph 1, this as a graph 1, and I will try to implement the same thing for graph 2. Let us see. So for graph 2, number of vertices 1, 2, 3, 4, 5, 6 are there. Edges, have a look once. 0 to 1 connection is there, 0 to 2 connection is there, 0 to 5 connection is there. Then 1 to 0 it is already established, 1 to 3 is there. Next we have to take 2 to 4 is there. So 2 to 4 and 2 to 0 is already registered. Then coming to 3, so 3 to 4 is there, 3 to 1 already established. Then take 4, for 4 already 2 is connected, and 4 to 5 we have to take. Okay, so here also not 3 to 4, it is 3 to 5. Like this we have. That's all right. First, we will print the graph. Later, we will check BFS. I am commenting BFS. Let me print first of all. Sir, is it correct? My graph is correct. So 0. Oh, unfortunately, I have given the color as black. Okay, no problem. For 0, which are adjacent? 1, 2, and then 5. 1, 2, 5. For 1, which are adjacent? 0 and 3. 0 and 3. For 2, which are adjacent? 0 and 4. For 3, which are adjacent? For 3, which are adjacent? So 1 and then 5. Okay. So for 4, which are adjacent? 2 and then 5. So for 5, which are adjacent? So 0, 3, 4. Like this we have. So hope you understood the concept very clearly. Okay. Sir, let me check the BFS. We will enable this BFS algorithm. Whatever code that we have written, is it correct? So 0, 1, 2, 5, 3, 4. 0, 1, 2, 5, 3, 4. Yes, perfectly it is working. So I think for the first graph, what output we got? For the second graph, what output we got? I think you people are clear with this. No need to give much explanation. So are you clear with these two approaches, two examples? Please confirm. For the previous, it is nothing but I think 0, 1, 2, 3, 4, right? 0, 1, 2, 3. Are you clear with this BFS approach? Please confirm.
Yes, sir.
This is nothing but BFS what we have. Okay. So next one is DFS. DFS means what? Depth first search. We have to go up to depth. So let us see how we are going to do that. Anyway, this algorithm we will see later. Just for your understanding purpose, I will take a simple example and I will show you. Let us take the first example, whatever I covered, 0, which is connected with 1 and which is connected with 2, and this is connected with 3, and this is connected with this, and there is a connection. For BFS, what output we got? 0, adjacent nodes 1 and then 2. So 1 adjacent 0 and 3, 2 adjacent 0, 1, 3 already visited, 3 adjacent 1, 2 already visited. This one. Sir, if you apply depth first search, first we have to take the node 0, which is adjacent to this 1. So take 0 and adjacent to this is nothing but 1. Don't go for this 2. Till depth you have to enter. Which is adjacent node for 1? 3. Go to visit that one. Which is adjacent to 3? 2. So visit that one. Like this you have to keep on visiting till the depth is reached. Okay. So this concept is called as what? Depth first search. Compulsory we have to use the concept of recursion if you want to implement this depth first search algorithm. Okay. So theoretically, are you clear with this approach, whatever I told? Please confirm.
Yes, sir.
Right. So let us implement this with the help of a program so that you will get some idea. Okay. Let us implement this with the help of a program. See, compulsory we have to implement by using recursion. One second. Let us implement by using some algorithm. Let us see. Okay, so I will disable this. I will disable this. Okay, and I will enable this because this is the program, right? What we covered. Right. So now after this empty print statement, I will try to call DFS and L comma 0 I am taking, 0 I am passing. Now, so we have to call DFS. Let us see how to implement the DFS. We have to implement based on recursion. That's why, so DFS I am calling. What are the arguments? We are going to pass a list and then we are passing a source node. So from where we have to start. So list is there, starting node is there. Now have a look once. See here, I'm going to make a recursion call. But how to check whether the node is visited or not? Because in the recursion, continuously we are going to make the calls. But how to check whether the node is visited or not? For that purpose, we will maintain one array and we will pass that array as the input. So what is that array here is visited array I am going to take. So which contains all the elements as a false into how many elements? Length of list. Now I will call another function like dfs utility function by passing the list and by passing the source, as well as I will pass this visited to keep track whether that node is visited or not. Now we have to define so dfs util function by passing the list and taking the source and then visited array. So since it is a recursion call, we have to implement based on recursion. Let us see what will happen. Sir, here first we are going to do one step. Please have a look once. Visited of whatever source we have given, that node we have to make it as a true. That node we have to make it as a true. Now, what is the first node source we have given? 0. So already we have visited array is there 0, 1, so 2 and then 3, right? So 0th node false, 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 like this we have. So 0 is the source. 0 is the source. Make this source as a visited. Okay. After this, what we are doing? After this, what we are doing? So here we are going to print that particular source, whatever we have. Comma end is equal to empty. So it will print that output. Yes, 0 came. Next, what we have to do after this? We have to call recursively, right? Okay, we have to call recursively. So for each I value in that particular list of source, which are adjacent to this list, try to maintain. So that adjacent will become 1, 2, right? So now first we are going to check. We are going to check whether is visited of that particular I is equal to false. If it is not visited, can you please call dfs util function by passing the list I and then visited? Please have a look once. Please have a look once. Sir, first I value is nothing but 1. Is 1 is visited? No. Then what we are doing? dfs util we are calling by passing so 1 as a source value. Okay. So that source we are making it as a visited, which is nothing but a true, and we will print that 1, which will be nothing but 1. Next, what we are doing for each I value in the L of source. Source is 1, which are adjacent to this 1, that we are going to take. So 0, okay, next and after that, which are adjacent to 1. So 0 and then 2 and then 3, like this we have. Okay, 0 and then 2 and then 3. So now what will happen? So is it correct? For 1 which are adjacent, 0, 2, 3. Now visited of 0. Is 0 is visited? Yes, it is already visited. No need to go for this. Next, take the second element, 2. Is it visited? No, it is not visited. So then what we are going to do? We are calling by passing the source as a 2. Okay, source node as a 2. Now we have to take that second node and we have to visit it. So what will happen? I think I have given 3 here. In depth 0, 1. Okay, maybe based on the adding you may get. Suppose if 1 to 2 connection is not there, then you can get clarity. Okay, no problem. So I think the concept you understood, sir. First let me execute and we will see what output we are getting. So for both we are getting same output. Better we will change the graph so that we can see is there any difference or not. So BFS, and we have to call DFS also. Now see, is there any difference? There is a difference. Now I will draw that diagram, sir. You will get clarity. What is this diagram? I think forgot. Is it just at the top level? I will explain. You can trace it later. So what is the first node? 0. Its adjacent nodes are nothing but 1, 3, and then 5, and its adjacent nodes are 2, and then 4, and then 5, and there is a connection. Now see. What is the output that we got? First, we will check. Okay. So the first node is output that we got. 1, so 3. And what is that BFS output? Now see. So DFS, please concentrate. So first we are taking the source node. We are printing that. Which are adjacent for this one? So immediately we are printing. Sir, we won't go for adjacent, another adjacent for 0. Immediately we are going for adjacent node of 1. In depth we will visit 3. Visit 3. Adjacent node for 3, 5. Visit 5. Adjacent node for 5. Visit 4. Adjacent node of 4. Visit 2. Like that, in depth we are going to come. That is nothing but what is DFS. BFS means what? First we will take 0, then visit it adjacent. So 0, 1, 2. Then 1 adjacent nodes, 3. Okay. So like this, we are going to see adjacent nodes first. So first level, next second level, next third level. But in DFS, first node, go to depth and then come back. Go to depth and then come back. Like this, it is going to work. I think at a top level, what is the difference between this BFS and DFS? You got a clarity, right? Any doubts? Yes, please confirm everyone. Are you clear with these concepts? Yes, please confirm.
Yes, sir.
Yes, sir.
Right. This is nothing but what is breadth first search algorithm and what is depth first search algorithm. In the depth first search, what we are doing, we are keep on visiting each and every element in depth. Okay, if you want just algorithm, I am going to take, I will copy paste here and you can see. So we have to visit each and every node exactly one, start from the source vertex and try to fetch its adjacent, its first adjacent element, okay, for the node, and visit till depth, okay. So visit, so till depth, till depth by using recursion, because you need to go in depth. So we have to repeat this process for every node. That's also nothing more than this. Okay, it's a very simple approach. Okay, so in these two ways we can visit these particular elements present in the graph. Okay, this is nothing but the first part what I covered. In this you can able to see what concepts we covered. Intro to graphs, what is mean by graph, then representation of graphs. So how you can able to represent by using matrix and how you can able to represent by using list. Then we have seen BFS and then DFS. Are you clear with these topics whatever we covered?
Yes, sir.
Right. With
Yes,
this,
sir.
I will stop today's session. So tomorrow also same timings we have a class. So tomorrow I am going to explain. So is there any path or not? Like has a path. I will give one source node and a destination node, and you have to check is there any path between that nodes or not. Okay. So after this, so we have to count how many paths are there. We have to count paths, how many paths are there. And we have to print all paths. For example, if there is 3 paths are there from 0 to 5. In our previous example, 0 to 5, almost 3 to 4 paths are there. We have to print all that paths. Okay. So next and after that, we are going to see, so shortest path algorithm. Next, we are going to see minimum, okay, minimum cost spanning tree. So there is one concept is there called a spanning tree. That part we will explain. Okay. So tomorrow I will explain these concepts. So tomorrow same timings, 5:30 to 7 o'clock I'm going to take the session. Okay. So tomorrow you can expect running notes and videos, everything. Tomorrow will be updated in every batch. TSA with Python batch 1, batch 2, batch 3. In all these 3 batches, all the videos like tree data structure videos up to AVL we covered, right? So that tree data structure videos, and today and tomorrow I'm going to take this graph, that videos, running notes, and bit manipulations already I have taken for one batch. That videos you are going to get, and priority queues. These videos you can watch. Okay, right, sir. Thank you. Any queries?
Sir, I have one query, sir. Where we can do this practice? Any website, sir, for
No,
your
no.
suggestion?
You
Data
have
structures.
no. You have to do it by your own. But if you want to solve some problems, we have. I will share that for you. Don't worry. Okay.
సార్ అంటే ఇంటర్వ్యూస్ ప్రిపేర్ అవుతారు కదా సార్, అమెజాన్ కి అది వీటికి ఆ కోడ్స్ అన్ని ఎక్కడ ప్రాక్టీస్ అయితే బాగుంటుంది సార్?
Things పంపిస్తాను.
సరే సార్.
Right, sir. Thank you. See you tomorrow.
ఎస్ సార్.